The first aspect in algebraic expressions that we'll cover is word statements. So rewrite each of the following statements as algebraic expressions. So there's our word statement here. The difference of a number and 5. A number in algebra is represented by the variable x. Difference is represented by the subtraction sign. And 5 is our constant given. So the difference of a number and 5 can be written in algebra as x minus 5. The next one, a number increasing by 7. A number can be represented by x. Increasing will be represented by a positive sign here, or plus sign, and our value is 7. So a number increasing by 7 can be represented as x plus 7. The next one, the product of a number and 3. Product means multiplication, a number represented by x, and 3 our value given. So the product of a number and 3 can be rewritten as x times 3 or simplified to 3x. The next one we go to is substitution. So we're given here, if x is equal to 3 and y is equal to 5, find the values of the first one given is 10x. Now in algebra, a constant next to a variable actually means multiplication. So 10x actually means 10 times 3. Brackets means times, so 10 brackets 3. 10 times 3 gives us 30. So instead of x, we substituted our x value, which was given as 3. So 10x became 10 times 3, which is 30. The second one here, x plus y. X is given as 3, so instead of x, we substitute 3. Y is given as 5, so instead of y, we substitute 5. So x plus y will become 3 plus 5, which is 8. We can go on now to flow diagrams in algebra. When you're working with flow diagrams, you usually have an input, a rule, and an output. Now the input values represented by the variable given will tie in with the rule that's given here. So if our variable is x and our rule is 2x, our output is 2x. If our input is 1, it means that we substitute in place of x 1. So instead of 2 times x, as you can see here, it will become 2 times 1, which is 2. So an input of 1 when the rule is 2x will be 2 times 1, and the output will give us 2. Same with the next input of 2. We substitute 2 in place of x, so 2 times 2 will give us an output of 4. The next one, we substitute an input of 3 for x, so 2 times 3 will give us 6. And the last one, 4. 2 times 4 will give us 8 there. You can also get tables in algebra. So let's work with this example here. Use the given rules to complete the relevant tables. So we're given our x values here as 1, 2, 3, and 4. Our y value here, similar to the rule in flow diagrams, the rule is given as y is equal to 4x. So it's substitution again. Instead of x in the rule here, we substitute the x values that are given. So y is equal to 4 times x. So 4 times 1 will give me 4 here. The next column, 4 times x value of 2 will give me 8. The next column, 4 times the x value of 3 here will give me 12. And lastly, 4 times the x value given 4 will give me 16. You can try this example here on that side to complete the table. Like and unlike terms. Like terms are terms that have exactly the same variables or letters in algebra. Unlike terms are terms that do not have exactly the same variables. So let's work with this example here. Group together the like terms in each of the following algebraic expressions and simplify. So we are given our algebraic expression of 5x plus 2xy minus 7 minus 3x plus 6xy. if we were asked how many terms are in this expression, it would be 1, 2, 3, 4, and 5. 5 terms. Terms are separated by plus and minus signs only. So there's 5 terms here. We need to group together the like terms. So our first term is 5x. That's an x term. Remember, we look at the variables only. The next term is an xy term. So that's not the same as the x term. So we will look for another x term in this expression, and we move along. Our x term is here. Our x term is not 3x. It's actually negative 3x or minus 3x. So we'll put those two terms together. So those will go first. That's 5x minus 3x. Then we keep going. We have positive 2xy. If we look for another term that's xy, it's this last term, which is positive 6xy. So we'll put those two terms together. Positive 2xy plus 6xy. And our lone term here is this negative 7. So we'll put the negative 7 at the end. Now that we have them grouped together, we can simplify them. So if we look at the blue here, 5x minus 3x will give me 2x. Our reds here, 2xy plus 6xy will give me a positive 8xy. And our lone negative 7 constant is just at the end there. So our simplified version of this algebraic expression is 2x plus 8xy minus 7.